My name is Rob Winch, and I'm the Spring Security Lead at SpringSource VMware. I've only been there for a few months, but I've been working on the Spring Security project for over 2 years now. And before that, I worked in information technology securing healthcare applications. Today we're going to be talking about Spring Security fundamentals, and we'll get started with today's agenda. We'll start off with Spring Security, what it is and how it can benefit you. And then we'll discuss how to set up a Spring Security application. Then we'll spend the majority of the time walking through how Spring Security is working behind the scenes. And we'll illustrate this with various diagrams. And then we'll do some very basic customization of Spring Security. And we'll end with a Q&A. Spring Security was formerly known as CG Security. So if you see a CG Security, know that they're one and the same, but also know that the CG code base is no longer actively maintained. So if you're starting a new project, or if you've already used a CG Security, make sure that you upgrade to Spring Security because that code base is still maintained. Spring Security is broken up into two main concepts, authentication and authorization. Authentication describes the who, or who's trying to request a particular resource. And that can be identified in a number of different ways. One of the more common ways is using a username and password, and that might be backed by various data stores like a database or LDAP. Spring Security supports both of these out of the box. It also provides mechanisms for securing your users' passwords. You may have seen on the internet that a number of websites have had their users' passwords compromised, and that malicious users have been able to extract that information and reveal the original password. Spring Security provides a password encoder interface that allows you to securely store your users' passwords using one-way hashes and salt to ensure that it's difficult, if not impossible, for malicious users to get that information out. There's also other mechanisms for authentication. For example, there's a couple different single sign-on mechanisms supported, CAS and OpenID. CAS is often used in academic world, and it has the benefit of providing single logout also. OpenID is provided by a number of the giants out there like Google and Yahoo. And another mechanism is pre-authentication. Pre-authentication occurs when you have an external mechanism authenticating the user, and then you still want to use Spring Security. But why would you want to use Spring Security if you've already authenticated? Well, that comes to the second aspect of Spring Security, and that's authorization. Authorization says, given I know who is asking for a particular resource, are they allowed to access that resource? And it's very important to keep these two separated. And in a web application, it's very typical to use URL-based security, but that often is not enough. And so Spring Security provides method-based security. And you could embed this logic into your code directly, but this makes it very difficult to maintain. So you could also use annotations on your methods and use Spring's aspect-oriented programming support to add authorization to your service tier. Spring Security also has a number of extensions demonstrating how, while it's simple, it's still very powerful. Some of the extensions include s-saml, s-oauth, and s-krb-lms extensions. And this demonstrates that while Spring Security does provide a wide variety of things, it might not address all your concerns because there's a lot of different security requirements out there, but it will provide a solid foundation for you to build on and expand and keep up with your security needs as time goes on. Before we get too far into the presentation, it's important to understand some of the basic concepts about servlet filters. And you've probably used them before, but there's a few key points that are necessary to understanding Spring Security that are often confusing to new users. So we'll go over those very briefly before we get started. Here we have a very basic web XML. In the web XML, we've mapped filter 1 to every URL. Here's the code for filter 1. Filter 1 is very simple. It does something before, and it prints out before request URL. You'll notice our terminology. We're using before request URL for the greater than sign. Then we run the rest of the application. The rest of the application is ran, and then we invoke something afterwards, and we read this as after request URL. This will be important in our illustrations later on. So here's a typical HTTP GET to home. let's see how this filter processes the request. The very first thing is filter1.doFilter is invoked. And there's nothing special about it. All it's doing is invoking the method that we saw previously. And so the very first thing that we should expect is that we see the output of before home. Next, we will expect the filterchain.doFilter method is invoked. And within there, we don't really know what is happening. We just know that it's the rest of the application. And this is important because the filter needs to be able to operate on any application despite what they're doing behind the scenes. In our particular application, we might have a servlet that is forwarding a request to home.jsp. And here you see that is exactly what we're doing. The home.jsp sees the request and writes the response out, and then it propagates back up to our filter. And then at the very end, after filterchain.doFilter is done being invoked, we output after home. And you might notice that while we have two URLs being involved here, the filter is only printing out one URL. And that might be confusing to some users. So how would we resolve this if we wanted the filter to intercept the forward as well? Here you see we've updated our web.xml to include the dispatcher for requests and forwards. And this means that it will now intercept the forward as well. By default, it only intercepts the request. So let's take a look and see how that modifies our flow. First, we get home. Filter1.doFilter is invoked, and it outputs before home. Our doFilter chain is invoked, and our servlet forwards to home.jsp. Now you'll see that filter1 also intercepts the home.jsp and outputs webinf home.jsp. The home.jsp is now activated and outputs the response. We then complete with the first filter one, or the second filter one's filter chain, and it outputs after webinf home.jsp. That propagates up to the servlet, which propagates up to the filter one, and now its filter chain is done running, and it prints after home. So you can see that we can easily update the dispatcher types and intercept other URLs. And while it's not very common to do this with Spring Security, it's important to be aware of the different dispatcher types. And you can see that the possible dispatcher types are request, include, forward, and error. And so you might not need all of these, but do be aware of them as you're building your application. Here we have another misconception cleared up, is the filter chain is not magical. It's just invoking the rest of the application. Let's expand upon this to illustrate the point. Filterchain.doFilter is invoked, and we can just word that as run the rest of my application. If there was a second filter in our web.xml, say, for example, security filter, it might be invoked, and it could be replaced by the filter chain. So think of filterchain.doFilter as just running the security filter.doFilter. There's not much of a difference. And in fact, if there wasn't another filter, it was just the same as invoking servlet.service. So again, filterchain.doFilter is just the equivalent of running the rest of the application. And why is this important? Well, if we're just running the rest of the application, we can add a try block. So we can try to run the rest of the application, and then we can catch exceptions. So with Spring Security, we might have one filter trying and catching, and another one performing security checks. So we might try to see if the user has access to the application, and then if there's an exception, we can catch it and send them to the login page. And this is how Spring Security is built, using small, discrete filters that are built to do a very specific function, and they're composed to provide a strong yet powerful security framework. So now let's take a look and see what our messages application looks like. And our messages application is actually quite boring, but it'll illustrate the point. Here you can see we have a messages application, and we can create a new message. Once we create the message, it's displayed, and then we can list it out, and we can view it. So again, our application is not fancy at all, and it doesn't have any security. So let's see how we can add security to this application. The basic steps for adding Spring Security are add the Spring Security dependencies, update the web XML, and create the Spring Security configuration. Let's look at this in more detail. So here you see a snippet of a pom.xml. If you're not familiar with this, this is Maven's way of declaratively stating what our dependencies are. And not only will it state these dependencies, but it will also pull in the transitive dependencies. For example, Spring Security Core depends on Spring Core. And so Spring Core will automatically be brought in. This has some nice things to it, but it also can cause some problems, which we'll go over shortly. Spring Security Core is the core dependency. If you need Spring Security, you need to have this dependency within your application. Spring Security Web is required for any web-based application, and Spring Security Config provides the Spring namespace support for Spring Security. If you're not familiar with Spring namespace support, think of it as a declarative way of stating your security configuration that makes it much easier to configure. We'll go over this in more detail shortly. Earlier we mentioned that there can be some problems with the transitive dependencies. And one of those problems is that while it brings in the transitive dependencies, it might resolve the wrong version. And one of the things that's important is that all your Spring dependencies match and all your Spring Security dependency versions match. And this is important because otherwise you can get some very strange errors like no such method and other sorts of errors like that. So here you can see that Spring Security is built on Spring 307. And so it's pulling in Spring Expression 307. However, the application has explicitly defined Spring Core 312. And that is pulling in Spring 312 dependencies. However, we get a clash. There's some Spring 307 dependencies and some Spring 312 dependencies. Again, this can cause some problems. One way to resolve this would be to add all the dependencies to our POM. Another would be to add a dependency management section to our POM. The difference is the dependency management will only bring in the dependency. It'll only state that any transitive dependencies should be resolved to a specific version, but it won't actually pull them in. So here you can see that the Spring expression is stated that if there is a transitive dependency, to pull in the 312 release version. And you would probably need to add more dependencies to the dependency management section, and the last bullet will highlight some of the more common ones in your application. So there's other ways to specify dependencies, and here's just a snippet for Gradle. If you're not familiar with Gradle, it's kind of one of the next generation build tools that uses Groovy, and you can see that the syntax is quite a bit more concise. Also, you can notice that from the bullet that oftentimes with Gradle, since the most recent version is pulled in, there's no need to do something like dependency management because the proper dependencies are oftentimes pulled in just by default. The next step is to update our web XML. In our web XML, the first step is to add the context loader listener. And that context loader listener requires the context config location. And what this is doing is it's creating an application context, which is a factory that Spring uses behind the scenes, and it uses that context config location to determine what configurations should be loaded. And so it's important that that context config location aligns with all your Spring configurations so that it all gets loaded. Once that application context is created, the rest of the application can use that application context to look up Spring beans. Now, while you can interact with the application context directly, it's very uncommon and, in fact, quite discouraged to interact with the application context directly because then you have a direct dependency on Spring. Instead, you can rely on other portions of Spring to do this stuff for you, and we'll look at that more in detail very shortly. Here is the next step for our web XML. We need to declare the Spring security filter chain. And this is where all the URL-based security is coming from. So we have the Spring Security filter chain. It's implemented by delegating filter proxy. And we map it to every URL in our application. And in fact, the filter mapping is typically the very first filter mapping in our web application because anything that's before it is not protected by Spring's URL-based security. So how does the delegating filter proxy work? Well, earlier we mentioned that the context loader listener creates an application context. The delegating filter proxy obtains that application context for us, and it will use that to look up the Spring Security filter chain. Why does it decide to look up the Spring Security filter chain? Well, that's actually a very simple convention. The filter name is the bean name that it uses to look up the filter. And it's required that the bean name for this name is an instance of filter. So when you're creating your Spring configuration, it's important that you have a Spring bean by the name of the filter name in your Spring configuration that implements filter. And we'll discuss how to create that very shortly. So once it gets an instance of the Spring Security filter chain, it assigns it to a member variable, and then anytime delegating filter proxy is invoked, it just delegates all the work to the bean that it looked up. And so you can see that delegating filter proxy is not really doing anything. The only thing it does is provide a bridge between the web container and Spring. You can think of it as I can create a Spring bean that implements filter, and I can have a container use that, and the delegating filter proxy is the bridge that provides that mechanism. So now that we have our web XML updated, we need to update our Spring security configuration. In fact, we'll need to create it. We'll go ahead and demonstrate how we can easily do this with Spring Tool Suite. Spring Tool Suite provides an easy mechanism to create Spring bean configuration files. And you don't need Spring Tool Suite in order to do this, but it can really make things easier. So you can easily create your configuration using Spring Tool Suite, and it can state your namespaces. So now that I've done that, I can click Finish, and you can see that it creates this declaration at the top for me so I don't have to remember any of this information. And if you need to add additional namespaces, you can easily click on the Namespaces tab. So this can really make things a lot easier for us when we're creating our configuration. So what does our configuration look like? This is a very basic example of how to use Spring Security. You would place this between the beans tags of our Spring Security configuration. And the first thing you'll see is the security HTTP element. And what this does is it creates the Spring Security filter chain that we have seen in our delegating filter proxy pseudocode. And what it does is it uses the intercept URL to determine if a user has access to a particular URL. So here, the pattern /** will match any URL. So any user will require, any URL will require the role user. The form login element provides the ability to, if the user is not logged in, it will send them to a login page, and it will then also validate the username password once it's submitted. So that's very powerful. And the authentication manager is what is used to validate the username password once it's submitted. So the authentication manager here is just an in-memory implementation. We mentioned a number of other data stores, for example, LDAP and database, and we could easily swap that out, but here we're using an in-memory implementation. And this just makes it very easy for us to get up and going fast. So here you can see that our user has a username of user and a password of password. And it does, in fact, have the correct authorities or roles for any URL in our application. So now that we have seen that, let's see what happens when we use Spring Security. I just needed to update our code very quickly to match what we discussed on our slides. And now we'll restart our server, and we will have Spring Security enabled. And here you can see that when I request the application, the very first thing we see is a login screen. And this login screen is not actually generated by any code that I have written. It is provided by Spring Security's form login element out of the box. So while it's not very pretty, it was very easy to get up and running. We'll see later how to customize this and make it look like the rest of our application if we so wanted. And we can type in a username and password. And once we've done that, we will be able to see the rest of our application. And the application behaves just as we saw earlier. So now that we've seen that we can very easily add Spring Security, let's see how things are working behind the scenes. So earlier we mentioned that the HTTP element is what creates the Spring Security filter chain behind the scenes. But what backs that implementation? It's actually known as filter chain proxy. And the filter chain proxy is very similar to the delegating filter proxy. The only difference is it can dynamically look up filters, and there are multiple of them. So let's take a look at the pseudocode here. The very first thing it does is, based upon the request, it'll look up all the delegate filters that it needs to use. And each of those filters are the small building blocks that we mentioned earlier. And so it'll iterate over each of those delegates. And as long as the delegate continues to invoke filterchain.doFilter, it'll continue invoking the filters. And once it completes all the delegates, it'll invoke the original filter chain. And this might be kind of complex to process, but what you can imagine is that this filter chain proxy is a way of making it so that you can specify a single filter in your WebXML and map it to a dynamic set of filters that are configured in Spring configuration. So you have a one-to-many mapping that is flexible based upon the current URL. And this is nice because otherwise you'd have to add tons of URLs or tons of configuration to your WebXML. And the fact that the container doesn't support all the different ways that we might want to flex the different filters. So let's see how this is working behind the scenes to get an idea. Let's say we request the URL messages. The delegating filter proxy will see that URL, and it'll invoke the filter chain proxy because it delegates all its work to the filter chain proxy. The filter chain proxy then looks up a series of filters, and only some of them will be doing something important. So we'll skip over some of the irrelevant ones, and we'll see that the exception translation filter is interested in this request. It's not actually going to do anything just yet, but it'll have a key part later. The security filter interceptor now sees the request, and it takes a look at our Spring Security configuration. And it says, does messages, our current URL, match /**? And notice this is coming directly from our intercept URL in our Spring Security configuration. Everything matches the /**, and so it requires the role user for the current request. And you can see again, this maps to our intercept URL pattern. The user is not logged in, so it's going to throw an access denied exception. And here's where exception translation filter comes into play. Just as we demonstrated at the very beginning when we were reviewing servlets, exception translation filter can catch the exception from the security filter interceptor, and it can send the user to the login page. So now it's sending a redirect to the login page. Well, we keep mentioning that /* matches everything, but how do I know what matches what? Spring Security uses AntPath request matcher behind the scenes in order to determine what URLs match. And by default, there are some rules. The query parameters are not included in the match. And this is important because if we included the query parameters in the match, it would be very easy for a malicious user to manipulate the URL in order to bypass security constraints. This is where our method level of security could catch things, but we want to be extra careful, and so query parameters are by default not included in the match. The context path is also not included in the match. And this is nice because if we redeploy our application, we don't want to have to reconfigure the Spring Security configuration. So you'll never have the context root in your Spring Security configuration. It'll automatically take care of that for you. Question mark matches a single character. Star matches 0 or more characters, except for path delimiters. And star matches 0 or more directories in a path. Let's take a look at some examples to further solidify this. So here we have /*. And again, we said this matches any URL. This is very self-explanatory, so we won't have any examples for this. /* matches anything in the root folder. So let's take a look. If our context root was /messages and our URL was /messages/1, the path minus the context root is /1. And so this is in the root folder. It will match. And you can see a few examples of what would not match. We could also have a match of /1234. That would actually match the /* because star will match on multiple things except for the / character. /1 /** will match anything that starts with /1. So one of the things that's more surprising about this is the /1/. It will match that URL because it does start with /1. The second / is optional due to the double star after it. And it'll also match multiple folders deep. So now the thing that's important is that these ANT patterns can be very powerful, but you need to be careful when you're using pattern matching. For example, let's say you wanted to grant access to all your CSS files, and you said use /*/star.css. This would match any URL that ends in CSS. So you could perhaps say grant access to any CSS files using this pattern. Well, the problem with that is while styles main.css matches, which is expected, /1.css would also match. So our URLs for requesting a particular message, a specific message, might be /messages/1. And the /1 won't match, but /1.css will. And the key here is the less restrictive the mapping, the easier it is for a malicious user to bypass that mapping. Spring MVC will treat /1.css the same as /1, so a malicious user can use this to bypass security constraints. There are other ways to bypass URL-based security, like using path variables, non-normalized URLs, etc. Spring Security does have things in place to help protect you, and you can see the Spring Security's HTTP firewall for documentation for more details on this. But because there are ways to bypass URL security, and it can be very fragile due to loose servlet specifications, it's best to combine URL security with method security, and this will provide the defense and depth that your application needs. In the event that one base security gets passed, the other one's there to back it up. You want the URL security there because it's the first line of defense. You don't want to forget anything, so the URL is a very broad and easy way to apply security immediately within your application. Method level security is nice if they happen to bypass that. So in this instance, if they were invoking the get message on our data access tier or our service tier, we could have method level security saying that even though the URL matched, that they aren't allowed to access this particular resource and it would still be protected. So going back to our example of what's happening behind the scenes, we just redirected the user to the login page. So let's see what happens when the login page is requested. Again, the delegating filter proxy is invoked, and it delegates all its work to the filter chain proxy, which has a number of filters that are not necessarily interested in the request, but some will be. In this instance, the default login page generating filter will be interested in this request, and it sees that the URL string security login means that it should write out a login page to the response. And this is where our very generic login page came from. So now that the login page is generated, the user needs to submit the username and password. And this will look similar to the following. They'll post to Spring Security Check, and they'll include their username and password. And the delegating filter proxy will see it and delegate all its work to the filter chain proxy. The filter chain proxy will again bring up the URLs or the filters for the specific URL And this time the security context persistence filter will say, I notice that the HTTP session has no security context. I'm not going to do anything just yet, but I'm going to play a key part later. A number of filters get bypassed, and the username password authentication filter sees the request and realizes, based upon the URL, it needs to validate the username and password. And I'll use our authentication manager for this. It submits the username and password to the authentication manager, and the authentication manager returns back a valid authentication. That authentication is set on the security context of the security context holder. The security context holder is where we can find information about the currently logged in user. And then at this point, the username password authentication filter will redirect the user to the originally requested URL. And the other thing that it'll do is the security persistence filter, context persistence filter will propagate up, and it notices that the security context was updated because the security context holder now has a user, and it'll take that and place it in the HTTP session. And it'll also clear out the security context holder. So now the saved request or the original request comes in, and the delegating filter proxy sees that, delegates all the work to the filter chain proxy, and the security context persistence filter again sees the request, and it notices that this time coming in that there is a security context in session. So it copies it over to the security context holder so the rest of the application can see it. And the security context holder is now populated. The request cache aware filter will see that it's a saved request, and it'll retrieve that saved request and replace it to our filter chain.do filter method. So earlier we mentioned that there's nothing special about the filter chain. It's just a method invocation. So we can actually replace the argument with saved requests that we looked up from our request cache. We don't actually have to pass in the original request. And this will ensure that anything that we were not able to encode in our URL actually is still present in this saved request. And now the security filter interceptor will see that the current user has role user, and that's because our security context holder is now populated. And since it does have the proper role user, it will now allow the rest of the application to continue and write out a response. And when it propagates up, the security context persistence filter will again check, and the security context has not changed. So while it hasn't changed, it doesn't need to update the HTTP session, but it does need to clear out the security context holder, because all this is a thread local that is holding the security context. And since in a container, servlet container, threads are pooled, it's important to ensure that value gets cleared out so we don't have a memory leak. So Spring Security is comprised of a number of filters, and each filter has a specific task. And it's nice that it's implemented as a filter because it's not specific to any MVC implementation. And that allows us to use it in a Spring MVC application, JSF application, Struts application. For whatever type of application you're using, the logic for setting up URL-based security is all the same. Another thing that's nice to understand is that while we've implemented these using filters, you could also implement similar logic using a controller of your choice. So if you wanted, you could actually validate the username and password using a Spring MVC controller, for example. And here's just a quick listing of some of the filters that we've covered, some of the other filters. And these filters are some of the more common security filters. You can find more documentation on the other ones on the Spring Security website, but this will just be a nice reference for you as you're going over the presentation later. And so we noticed that our login page was pretty hideous. It did get the job done, but it did not look like the rest of our application. And so let's see how we can create a custom login page. The first step is to update our form login element. And all we need to do is add a login page attribute, which specifies the URL of our login page. And what this is instructing Spring Security is that the /login URL will be where it redirects to, and it will also instruct it that we are now in charge of rendering the login page. You can also specify other attributes like the authentication failure URL, which will be the URL that it redirects to if a user failed to authenticate. And as we highlight here, it's important that you notice that any of the Spring Security configuration will not have the context root in it. That is automatically taken care of for you, so don't include the context root of your application in your Spring Security config. So let's take a look and see what happens with our new configuration. We request messages just as we did earlier, and much of the same thing happens. The only difference is this time the exception translation filter redirects to messages login, which is the URL that we configured in our Spring Security configuration. So these are the exact same steps that we saw earlier in the presentation. Now the web app requests login because it was redirected to it. And again, the same steps are performed, but you'll notice that this time the login generating page filter is not invoked, and that's because login is not the URL it's listening to. And so instead, what happens is it continues through the filter chain, and it gets to our security constraints. And it says /*, does that match /login? Well, everything matches /*, so it requires role user. And the user's not logged in, so it's going to send the user to the login page. And you probably have already seen what the problem is but we're getting into an infinite redirect situation. It continually redirects to the login page. So how do we mitigate this? We need to add another intercept URL pattern to grant access to the login page. And it's important to note that the intercept URL patterns are considered in order. So it's important that the intercept URL for a login page is inserted before the pattern that matches everything. Otherwise, the intercept URL for login will never be invoked. So let's take a look and see what happens now. The /login page is requested, and everything is allowed to bypass. We skipped over some of that logic, but it's granted access. And the problem is that nothing's configured for /login because our filter is not generating the login page for us anymore. We need to do that ourselves. So what's happening now is we're getting a 404. So it's important that you handle the URL that you've configured for the login page. And here we've used Spring MVC in order to do that, but you can use any way you want to process that URL. So again, you could use JSF or struts or some other mechanism in order to process that. It's just important that whatever you've configured, you process that URL. And that the processing of it can be done with any rendering technology that you want. Here we've used a JSP, but you could use something like FreeMarker if you wanted as well. The important thing is that you have a form that posts to JSpring Security Check and includes the username and the password using j_username and j_password. And in fact, actually, those are all configurable. So here you can see that what the form login requires the login page to do, but you can also see that most of this can be overridden using additional attributes on the form login element. So for example, the login processing URL is authenticate here. So that means that if we wanted to use this configuration, we would post to authenticate with the username and password sent to username and password rather than j_username and j_password. It's oftentimes good to customize this information so that it's less obvious that you're using Spring Security, because that basically is an information leak that allows malicious users to know more about your application. So oftentimes customizing these defaults is a good practice. So one of the problems that we would notice if we had ran our application is that with our custom login page, we would not be able to access our CSS files. And so it may be to our advantage to do multiple HTTP elements and grant access to our resources. And we could just use the permit all, but we want to demonstrate the HTTP element. And oftentimes, when we're using static resources, we'll use security equals none. And this differs from permit all in that security equals none means that the rest of our filters in our filter chain will not be invoked. It just skips over them entirely, whereas a permit all just instructs it to grant access. Let's take a look and see what this looks like. So first we request main.css, and the delegating filter proxy sees it and delegates all the work to filter chain proxy. And we've been skipping over this a little bit, but the filter chain proxy actually has some logic in there that we saw in our pseudocode. It needs to figure out which delegates it delegates to. And so here it takes a look at our Spring security configuration. And the first thing it does is it looks at our first HTTP element. They're also considered in order. And it'll see that the pattern is resources /*. So if the URL matches this, then security will be disabled because security is set to none. And resources main CSS does match resources **. And so yes, we will skip all the security filters. And you'll notice it doesn't continue to the next HTTP element. It stops there because once an HTTP element is selected, it stops with that. So now, instead of going through the filters, it actually goes directly to the main.css because it didn't find any delegates. Let's take a look at it for our messages request. The delegating filter proxy will see the request. Filter chain proxy will now use our configuration to look it up, which filters to be invoked. And it looks at the first HTTP element, and it says that resources does not match our current URL. So it'll skip to the next HTTP element. And now there's no pattern on this HTTP element, so that defaults to /*. And that explains why I was working earlier when we didn't have a pattern on there. So the pattern on this element is **, so that means that we're going to use this HTTP element, so we can use these security filters. Now it knows which filters to delegate to, and we continue through the process that we were familiar with now. Security filter interceptor looks at the intercept URL, and it says, does messages match /login? No, it doesn't. Does messages match /*? Yes, so this URL requires role user. Let's take a look at one more example and see how if we modify our configuration, what will happen. The delegating filter proxy will be invoked for the main CSS, and it'll delegate all the work to filter chain proxy. And now we've got a slightly different Spring security configuration. Here you can see the first HTTP element is no longer using security equals none. Instead, it is protecting admin.css. And so this isn't gaining us a lot for this particular configuration, but it will illustrate a point. So it'll ask, does pattern resources ** match our resources main CSS? And it does. And so it'll use the security filters for this HTTP element. And it looks those up, and now our security filter interceptor will say, does main CSS match our pattern, which is resources admin CSS? It does not. And there's no more intercept URLs for this HTTP element, so access is granted. And you'll notice that there is another HTTP block, but it won't go to that next HTTP block because, again, once it goes into the first HTTP block, the first one it matches, it will not continue to another HTTP block. So it's important to keep this in mind when you're securing your applications. So that's all we have for today. If you have additional questions, please feel free to visit the forums at forum.springsource.org. You'll be able to find the recorded version of this presentation on YouTube and at the SpringSource developer channel. If you want the source for this presentation, you can visit GitHub at github.com/winch Spring Security Fundamentals. And if you want more information, please feel free to visit the homepage to learn more. These slides will be available later on through springsource.org. So I we'll now go ahead and do our Q&A. Let's see what the first question is. Someone asked, that's answered. Let's see. So some places we have a custom context loader listener which doesn't extend context loader listener. This seems to present a challenge. So I guess I would ask you, why are you creating a custom context loader listener, and what are your challenges? The important thing is that the Spring Security context is available to the delegating filter proxy. And if that's not available, then it cannot actually look up the filter. So basically, you need something to, there needs to be something to bridge that gap between the Spring configuration and the container lookup. So if you're doing a custom context loader listener, it needs to do much of the same logic. It needs to make the application context available in the same manner that the context loader listener does. And furthermore, it needs to also make the Spring Security filter chain available to be delegated to. So someone's asking how to dynamically assign a role or group to a component. And this is a common question. And a lot of people ask, to kind of add on to this is a lot of people are looking for the ability to, instead of using the URL mappings in a XML file, they want to be able to do it in a database. And this is possible. In fact, it's covered on the Spring Security FAQ. So if you visit the Spring Security FAQ, it'll discuss it. But one of the things that's key to remember is that you might set up all your configuration and then do a lot of testing. And as we mentioned, URL-based security is already a little bit fragile and difficult to get right. So you'll do all of your testing, and then someone will update the database. And then you might actually have a vulnerability. And so it's very important that you realize that by putting it in a database, you basically ruin all the testing that you have done if you update the database. So keep that in mind. But there is the ability to use any sort of mechanism to obtain all the security metadata, and that is covered on the FAQ. If you have further questions, again, you can use the forums to ask, but the FAQ does cover how to do that. Very good question. So another question is does Spring Security have support for Jazz? So Spring Security, you can authenticate with Jazz, and that's covered in the Spring Security reference, and it basically allows you to delegate to login modules. And 3.1 has some extended support for Jazz, but yes, it does support Jazz. And there's also a question, is there support for SSL certificate-based authentication and authorization? There is. A lot of that is actually dependent upon the container, because there's a specification for mutual authentication with the container, because Spring Security is not doing the handshake for you. It's the connector within your container. So, for example, Tomcat, and then Tomcat can make that certificate available for Spring Security to use as a pre-authentication mechanism. So, in short, yes, it is available, but Spring Security will not be authenticating the certificate because it's too early on. It's when the SSL handshake is going on. So someone says, is there an alternative way of setting the role? And they're wanting to know if you can do dynamic role assignment. And so, again, yes, you can do that. It's not necessarily encouraged because of the ability to cause security vulnerabilities, but you can do that using the FAQ information. So someone is asking, please elaborate on how a pure REST application without a login form could handle user password authentication. How does it hook up with the Servlet container to get the session ID, and who is persisting the security context and how it maps against the JSession ID? So let's do a couple of these. We'll go out of order. So the security context is persisted by Spring Security within the application context, and that was highlighted in our slides. It's one of the filters that's doing that, and it does that by placing it into the HTTP session. And it hooks into the container using a security context repository. And so you can swap out that interface if you wanted with another interface that is covered in the Spring Security doc in further detail. And then how would you go about using it without a login form? So if you're wanting to use username password authentication with your REST service, you would be able to use basic auth with it, and that would work just fine. Another way to do that would be to use OAuth. It really depends on your application circumstances, what type of authentication and authorization you would be doing. And someone asks, can you go over how this would work with CAS? That's actually a lot more detail than we can probably cover in this in the Q&A time, but there is a great documentation within the Spring Security reference that talks about CAS integration. And I don't think we really have time to go over that in any detail within our Q&A time. But in summary, you would really just need to update your Spring Security configuration, and how that's done and what you need to do for that. You would need to refer to the reference. How does Spring Security work with Spring Social? It's actually a really good question. Right now, Spring Security and Spring Social are rather separate entities. Spring Security does provide OAuth support, but it doesn't directly integrate with Spring Social. Spring Social actually does provide a hook to integrate with Spring Security. And one of the differences between the two approaches of Spring Security OAuth and Spring Social are that Spring Security tries to be less invasive. You aren't really aware you're using OAuth. Whereas Spring Social, you are aware of it, but it kind of hides some of the details of how it's being done from you. And so it really has a slightly different approach. There are thoughts on making this more integrated in the future, but that has not been addressed yet. It says, do you have any samples using on methods? I'm assuming this is the method-based security. And yes, the Spring Security reference mentions a number of sample applications. So you can go out there and see, you can see how it would work to protect your methods using aspect-oriented programming.
Rob, there was a related question to that about if the sample application that you were showing during today's webinar, if that was going to be, if that is available for download, or if that is in GitHub somewhere, perhaps.
The sample itself, it is available in GitHub, and I can bring up that URL again. Well, I guess I'm not sharing it anymore. I did bring it up at the very end of the presentation, so if it's pretty easy to find. Just go to GitHub, and my ID is rwinch, so R-W-I-N-C-H, and you'll find the Spring Security Fundamentals project out there. So, yes, it is available. I apologize. I did not post that up very long. But yes,
no worries. Google is a great resource.
Yeah.
Thanks.
Yeah, so go to rwinch on GitHub, and you'll see it there. Let's see.
Next question was how they implement stateless RESTful service without using HTTP session. Thank
you very much. Yeah, so the way that you would do that really varies depending upon what you're trying to achieve. A lot of people are scared of state within a RESTful application. And REST is meant to be stateless, but it also allows state to optimize things. So for the way that I try to perceive it is, if you authenticate every time, your application is probably going to be slow. No different than if you did a database lookup every time. So oftentimes it's very beneficial to have some sort of cache. An HTTP session should just be perceived as a cache specific to your security context. Now, I will say that a lot of people may disagree with my statement there, but that is my way of looking at it. However, if you disagree with my statement, Spring Security is very flexible, and you can use the security context repository and swap out how the security context is being mapped and stored. So, for example, if you wanted, you could map it to a NoSQL database or something like that. So you do have some options, but do keep in mind that one way of looking at the HTTP session is it's just another way of caching things, and your container probably already has support for making the HTTP session highly available, replicated, and redundant and performant. So keep that in mind. But if you don't like that answer, you can always implement the HTTP security context repository, and map it to a NoSQL database.
Next question was from John Frunsick about do you have some tips for handling AJAX requests in Spring Security?
Thank you. Yes, one of the main things that you'll need to be aware of is that whenever you make a request, if you're not authenticated, it needs to do something. And so Spring Security needs to be aware. And typically in an AJAX application, you'll need to either send the user to a login page in the event that they were, for example, making a request through the browser, typing in the browser a direct URL. So you might send them to a login page. But if it's an AJAX request, you'll need to handle it slightly differently because redirecting to the login page is kind of meaningless. And so what you can do is the login page, you can actually make it aware of the different content types, and it can do content negotiation. So for example, if it's an AJAX request or maybe a JSON request, it might send back an HTTP status code. And if it were a request for HTML, it might do a redirect to the login page. And so it's very simple to update your login page using the exact same setup that we described if your framework supports content negotiation. And Spring MVC does this very easily, so that should hopefully get you started at least.
Next question I think needed a little more clarity, Rob, so I'm going to skip it for the moment.
Okay.
And I think the next one was from Srikant. I think I'm not going to try to slaughter his last name there. Geronimo Raju, perhaps. Could you please show an example of configuration of a pre-authenticated scenario? Or can you just talk about that a little bit?
Yeah, we can talk about it. So one of the examples, an example of pre-authentication scenario would be if you're using SiteMinder. SiteMinder acts as a proxy server in front of your application, and it ensures that you're already authenticated. And it'll inject into the headers the user's information. And Spring Security will use that information, extract it, and then use that information to determine if the user is authorized. Another example that's similar to pre-authentication but actually an even simpler use case is when you are signing up a new user. So for example, if you want to sign up a new user, you may want to log them in immediately after they've signed up. And a lot of people try to use the authentication manager and authenticate the user, and then after they've authenticated them, then they try to set the security context holder. But the thing is as long as you set the security context holder with the appropriate information, Spring Security uses that and treats it as an authenticated user. So however you want to populate the security context holder, it's up to you. So you could just create the objects and set it on the security context holder, but at that point you need to be aware that you are in charge of validating that the user is authenticated. Spring Security cannot guarantee that you didn't mess up.
Well, this is great, Rob. We've got a nice stack of questions still going. So if you're up for it, if you're up for continuing, we can go along. How do you feel on time?
Yeah, we can continue on for a little while.
Okay, great. Madhuri asked a question about could we see another class or another webinar going into authentication, perhaps? Are we considering that, or might there be a resource online that we could point him to, or both?
There are. If you actually Google for QCon, InfoQ and my name, you'll see different types of authentication discussed. But I think there is probably room to expand on that. We were covering multi-tenant authentication in the QCon for New York recently. But there is probably room for us to add onto that, and I think we will try to do some more Spring Security webinars as time permits. So that is definitely a good topic for us to go into.
I agree, and if for audience that's still with us, as it looks like there's a fair amount, if you have thoughts on what you would like to see in the future, please, by all means, do add them into the question and answer panel on what topics you'd like to see webinars around, and we will certainly take that into consideration. Thank you for that. Next question, again, was it the same gentleman? Yeah, it's the same gentleman, but I believe he's actually left the web conference, so I'm going to skip that one. Okay. Daniel was asking a question, Daniel Mikusa, asking a question about, are there any plans for two-factor authentication support with Spring Security, perhaps integration with Google Authenticator?
There are no, so it is planned, but it is not, I guess, immediately planned. The current approach for doing such a thing would probably be doing a pre-authentication type scenario where your controllers are doing the logic, and then you would, after doing so, you would set up the security context manually. So there are some thoughts around how we would go about doing that, but right now Spring Security is actually focused on catching up with some of the Spring core Spring features, like we're hoping to add Java-based configuration, which is one of the most requested features. If you have additional features that you want, please visit our Jira, and that's on the main Spring Security page. There's a link there. Visit our Jira and either find the existing Jira and vote for it, or add a Jira, because we do use the voting to determine what features get added in what order. So if you do have requests, please feel free to do that.
Excellent. Okay. Let's see. Next question was from G. Peeve. Are 404s a special case, and how should they be handled?
I'm not sure that I understand that question, but a 404, as long as, in terms of security, I mean, as long as you don't care that a user sees your error page, then you probably don't need to secure it. Without more context, I think that's difficult to answer. I'm not sure that I'm understanding that question. So
yeah, I agree with you. If you're still on the line, please feel free to. It looks like you are still in the webinar. Please feel free to ask, clarify that if you'd like. Another question from Amir Salam. Does Spring Security provide auditing capabilities?
Spring Security does not provide auditing capabilities, but a lot of your data access frameworks will do that for you. So, for example, I believe that Spring Data provides mechanisms to do this, and even some of the ORMs like Hibernate have auditing support, as far as I'm aware. So, a lot of times this is more related to your data access framework, which will vary a lot depending upon, which one you have chosen.
Rob, I know aspect-oriented programming is frequently mentioned as a way to deal with cross-cutting concerns like logging and auditing. Might that offer a solution as well, or does aspect-oriented programming not play well with Spring Security?
AOP is the way that our method-level security is typically implemented, but a lot of times your auditing needs to go to some sort of data store, and so oftentimes you'll have some sort of you'll choose your data store implementation, and that will have tools for auditing, and then you can use Spring's AOP support, which is actually not tied to Spring Security. Spring Security leverages it, but it's more core. So Spring Core provides AOP support that can do that, but a lot of times you're already doing a lot of these things through your data access tier, and the data access tier will have hooks behind the scenes to do the auditing for you automatically. It's not necessarily with AOP, but it's basically event-based mechanisms within the data access tier itself. So basically, in summary, I would look at what you've chosen for your data access tier and see if it has auditing support. Okay.
Arlene Kearns is asking a question that, unfortunately, it seems to be a little out of context. She's saying, is securing a RESTful service done the same way? I'm just not sure what she means.
Yeah, I can take a stab at what she means, but I agree. I think it might be a little vague, or I might be misinterpreting it.
Why don't we have her clarify then, because we've definitely got a bunch of other questions and we're already way over time.
Sure.
So, Arlene, if you're still on, feel free to try to clarify. Aaron Harshberger asked a question, if utilizing a single sign-on approach, how does Spring handle that with receiving a token from an external system? And what's the best tool to monitor that filter chain? Sort of related question from the same guy. So if you're doing single sign-on, I would imagine it's SAML, right? But how does Spring handle receiving a token when doing single sign-on from an external system?
Well, I mean, it can vary. I mean, SAML or CAS, OpenID kind of has a token as well. So basically, the way that you can think of it is a lot of times with Spring Security, you'll have a core underlying library, like, for example, OpenID for Java, or the JSIG CAS library, or, it might be the OpenSAML libraries. And what it'll do is it basically acts as a controller, and it provides nice abstractions so that you can have multiple different implementations. And it'll delegate its work to the underlying library. And it'll also provide some conveniences, for example, making the namespace support to make the setup of it easy and stuff. So I'm not sure that I can answer it in any more detail without knowing more details about the question, but I think that gives a vague idea of the answer.
Appreciate that. And, Rob, one thing I'm thinking about, since there seems to be an abundance of questions and we're already at 10 minutes past the hour, perhaps you and I could work together on posting the Q&A to a blog on SpringSource where people could comment and there could be some dialogue. Just a thought. Another question from two people, actually. So this is a twofer, and I think maybe this is going to have to be one of the last ones as we're starting to wind down in terms of our online participants and potentially your time. But there was a question about, is there a good tool to monitor the execution of a filter chain?
Well, Spring Security has a debug element that will demonstrate what is actually being invoked in the filter chain, and so you can just add, it's very similar to the form login and the HTTP element, it's just the debug element, and you can view that in the Spring Security documentation. And basically what it does is it prints out basically debug information about what's happening behind the scenes. So that's probably your best mechanism. The other thing that you can do is in your IDE add a debug point to the filter chain proxy, and you can step through the code. So if you're trying to debug Spring Security, that's often the best place to add your debug point because it's the main entry point into Spring Security.
Got it. Hang on just a second. Sorry, I lost my place. I was just trying to see how many more questions there were. And boy, there are a lot. So this is great. I really appreciate all the questions. Rob, just a quick head check. How are you doing on time? We have about 124 people remaining online.
Yeah, I'm actually going to have to skip out here pretty shortly.
Okay.
I think we probably have time for maybe one more question.
Okay, very good. And, perhaps what we could do is look at addressing some of those questions in a blog post. So for attendees on the webinar, if you ask a question that we were not able to get to, we'll work together for, maybe getting those questions answered at some point and posting them online. And when we send you the thanks for attending email, maybe we can get a link to a blog post there, or just keep an eye on SpringSource.org for answers to your unanswered questions. And thank you very much for the participation. I think we'll take the last question. Let's see. Hold on. I'm just kind of scanning a little bit. Let me make the last one a good one. Okay. Question from Mohan Krishnan, excuse me, would we consider a similar webinar or presentation with CAS and LDAP configuration?
I'm sure that we could consider that, but it's I'm sure we would consider that. That's actually an excellent topic. CAS has quite a bit to talk about, so that would be something we would consider talking about.
Okay, great. Fantastic. Well, listen, thanks everyone for joining. Lots and lots of questions. I'm sorry we couldn't get to them all. Boy, there are a lot remaining. That's great. So clearly we've got some communicating to do around Spring Security. And Rob, thank you very much for joining us today and the excellent presentation and such attention to detail with the Q&A. Really, really appreciate it.
All right. Thank you, everyone.
Amy, back to you. Is there any wrap-up you wanted to do? Okay. All right, folks. Well, thanks a lot, and stay tuned. We've got some interesting webinars coming up in November, December. We're going to have Spring Hadoop on November 7th, I believe. I might have gotten that wrong. It might be the 8th. Check SpringSource.org back for more webinars and our webinar schedule in November and December. We've got some exciting content coming for you and some great speakers, and rest assured that we will have Mr. Winch back on the webinar program again. So have a great day, everyone. Thank you for your participation and your questions.
All right. Thanks again, everyone.